In this video, I will share the method how to derive an expression for electric potential difference between 2 points lying in electric field of a source charge. For this purpose, let me consider a point source charge anywhere. Suppose it is at point O and source charge is positive with magnitude Q. Our question is, this is a point A in its electric field. There is another point B within the electric field. Question is, what is the potential difference between A and B? First of all, let me share the definition of electric potential difference. Electric potential difference between A and B, I denoted by VAB, is defined as amount of work done in moving a test charge from A to B this way. Test charge is Q. If WAB represents amount of work done in moving this test charge plus Q naught from A to B, if I divide this by the magnitude of test charge, then the result I get is called electric potential difference between points A and B. So, potential difference between 2 points can be defined as amount of work done in moving a unit positive test charge per unit, means unit positive test charge from one point to the other. Condition is the value of Q naught should be very small so that it does not disturb the source charge. So sometimes we write this thing as limit Q naught tending to 0. It means Q naught should be very small. By using this definition, we shall derive expression for potential difference between points A and B. For this purpose, let us consider a point on the path from A to B at distance, suppose x, from the source charge. Suppose this small displacement is denoted by dx vector. When our test charge is lying at point P, it will experience electrostatic force or repulsion due to this source charge. It will be in this direction. So small amount of work done during small displacement I have denoted by dx vector. Let me denote this small amount of work done as dw. By definition of work, it is dot product of force vector and displacement vector. In this case, angle between f and dx vector is 180 degree. So I can write f dx cos 180 degree. Cos 180 degree is minus 1. So I get minus f into dx. Now we have to put the values of this Coulomb force. F is equal to 1 upon 4 pi epsilon naught into first charge into second charge divided by square of the distance. Distance between them is x, it is x square. By putting this value of f here, we can find value of dw. So small amount of work done can be written as minus 1 upon 4 pi epsilon naught q naught divided by x square into dx. Now we have to calculate total work done in moving from A to B. For that purpose, I will have to integrate this equation. So next step becomes integrate both sides. Integration dw equal to, by taking all the constants out of integration, I can write integration 1 upon x square dx. Now what are the limits of integration? I am starting from point A, I will terminate at point B. So maximum value of x can be this much, Let me call it distance RA, that is distance of point A from the source charge. Similarly, let me suppose distance of second point B from the source charge is RB. So these are the upper and lower limits. Starting limit is RA, we are starting from A point and we are ending at B point, it will be RB. Now we have to solve this integration and get our required answer. This integration will give us x raised to the power minus 1 upon minus 1 limits RE and RB. Now I will apply these limits and get answer for total work done. Integration dWW equal to Q naught upon 4 pi epsilon naught inside 1 upon RB minus 1 upon RE. So this is the value of work done in moving the test charge from point A to point B. If I divide this work done by the test charge, I will get expression for potential difference. So from previous question, I can write W upon Q naught is equal to 1 upon 4 pi epsilon naught Q 1 upon RB minus 1 upon RE. Now W upon Q naught is nothing but potential difference between point A and B. So this can be written as 1 upon 4 pi epsilon naught Q upon RB minus 1 upon 4 pi epsilon naught Q upon RA. Now this is nothing but potential at point B, and the second expression is potential at point A. So we can write potential difference between 2 points is equal to potential at point B minus potential at point A. This is another definition of potential difference. Potential difference between 2 points is equal to the difference of the potentials at those points. That's all.